In this video, we're going to talk about the applications involving right triangles. Before we jump in, it's really important to remember the basic components of a right triangle. So if I have this right triangle here, A, B, C, I know it's a right triangle because it has this little square thing in the bottom that indicates to me that it is a 90-degree or right triangle. And just a reminder that if I have angles A, B, and C, the opposite sides to it are going to be like little a, little b, and little c. We denote sides by lowercase letters and angles by uppercase letters. That's the word. And remember the Pythagorean theorem. So the two legs, you square those lengths and it gives you the square of the hypotenuse. And that any other two angles that is not the right angle, like A and B, will add up to be 90 degrees. And you can't forget that right angle trigonometry exists, and SOHCAHTOA is wicked important for that. So don't forget that. So let's take a look at this first example. It's asking us to do something called solve the triangle. So we're going to be given a certain amount of information, maybe an angle, maybe a side, maybe a combination of the two, and we have to solve for the other side lengths and angle measures within the triangle. So right now I'm given angle B is 40 degrees. I know C is 90, which will help me find A, and I only know one side, and that's A equals 2. So I'm going to use this information to find angle A and sides B and C. So the first thing that I'm going to do is I'm going to find angle A. So if B is 40 and C is 90, 90 plus 40 gives me 130, and if I take that away from 180, that's going to give me 50 degrees. So angle A is equal to 50 degrees. Easy enough. And now I have to solve for C and for B. So I can do this in a couple of ways, but I'm going to use SOHCAHTOA to do that. And let's start with side B. So if I am looking at angle B, that is going to be opposite of me, and the other side that I know just happens to be adjacent to me. So O over A, if I remember in SOHCAHTOA, that's tan. So what that says is tan of 40 degrees is equal to O over A, and opposite of me is B over 2. So I'm going to use my graphing calculator, and I'm going to plug in tan of 40 degrees, remembering to be in degree mode, because if I'm in radian mode, that will screw everything up. And what I'm going to do is I'm going to cross multiply and multiply that by 2, and I get that the side length of B is about 1.6782. And that makes sense, because I'm never going to have a really perfect triangle in this situation. So we have one last side to solve for, and I could use 40 degrees again, but I'm going to give 50 a shot here. It doesn't matter, you could use a different trig function with 40, but I'm going to try 50, because why not? So from the 50-degree angle, I know that C is my hypotenuse, and I can pick any other side, but I'm going to pick A equals 2 because that's a nicer number to work with, so that is opposite of me. So if I'm using SOHCAHTOA, that means sine of 50 degrees is equal to O over H, which in this case is 2 over C. And I'm going to do the same thing that I did over here and solve out for C. So I do a little cross multiplication here, and I'm going to get C times this equals 2, so I'm going to divide 2 by the sine 50 to get my C value, just manipulating it a little bit. And I use my graphing calculator in degree mode to find that C is going to be 2.6-ish. And that is how you would solve a triangle. So now let's look at another example where we're asked to solve the triangle again, but I am given no extra degree measures, so I don't know what A and B are, but I'm given two side lengths. So this applies the same principles, but kind of backwards, and I'll show you what I mean by that in a moment. So I'm going to use the Pythagorean theorem to figure out what C is going to equal. So that's going to give me 2 squared plus 3 squared equals C squared. Solve that out. And that's going to give me the square root of 13. Now you may be thinking, all right, that's not a classic triangle. So what is A and B? So I'm going to actually use what we call arc sine, arc cos, arc tan. We're going to use an arc function or an inverse function to find the angle measure. So I'm just going to pick angle A and 2 and 3 because they're nice whole numbers. You can start at B and do the same thing. It doesn't really matter. I'm just going to start at A. So 2 is opposite of me, and 3 is adjacent of me. Using SOHCAHTOA, I know that that is tan. So what that means is tan of whatever degree A is the ratio of 2 over 3. Now that's nice, especially because in my graphing calculator, I have these buttons above sine, cosine, and tan that have these little negative ones, and that means arc sine, arc cos, arc tan, and that will help me find the angle that I'm looking for. So if I have the trig ratio, like 2/3, and I plug that into tan to the -1, for example, and instead of plugging in an angle that I know, I'm going to plug in the ratio, like 2 divided by 3. That'll kick back the degree, if you're in degree mode, or the radian in radian mode, of the angle that you're looking for. It's a beautiful thing. So let's do that. It's really quite as simple as using the calculator, and I calculated A to be about 33.7 degrees. So from here, I could actually add this 33.7 and 90 and subtract it from 180 to get B. But let's just take a moment and solve it out just to make sure that we did that correctly. So if I'm at angle B, I'm going to use 2 and 3 again. So 2 to me is adjacent, and 3 is opposite. So I'm going to use the same tan function to help me out. You could also use radical 13 as the hypotenuse if you really wanted to. If that was a nice number, you would just use sine or cosine instead. So I'm going to say tan of B is going to be 3 over 2, and let's use my graphing calculator to do that. So I get 56.3 degrees roughly. So let's add these 3 angles together to see if we get 180. And we do. So you could either use simple arithmetic after you get this one, or you could solve it out and prove it using both tan functions. Up to you. That's going to do it for this video. Very nice. Thanks for watching.